Hey guys, here is the third day of notes on section 6.4. This will be the last day of notes on this section. Just a couple questions I want to go over with you that you'll see in the homework. And then other than that, it's just finishing up all of your work on My Math Lab. All right, it says, let f of x equal 6 cosine x. And then they're going to ask you a series of questions based off of this function. So I think some of the questions they're going to ask you, it's easiest if you whip up a graph of it really fast because it's not that hard to graph it. So I think it would be the best way to go. So let's say f of x equals 6 cosine x, right? So let's graph it. Well, the first thing I think you should do is establish who the parent function is, right? Before this graph was changed. Well, that would just have been cosine x. So f of x equals cosine x. So if you remember real quick what the graph of cosine x looks like, it starts up here at 1, it goes down and then back up. That's the cosine wave on one cycle or one period, right? So it goes from 0 to 2 pi, and then it goes from 1 to -1. Okay. So if you remember, the way you can whip up its key points really fast is that the interval from 0 to 2 pi was broken up into 4 sub-intervals. So take the period, 2 pi, and divide it by 4 into 4 subintervals, and that gets you pi over 2. So every pi over 2, you create this subinterval and a key point. So you had 0, 1 pi over 2, 2 pi over 2, which was pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi. And that's how you can get your 1, 2, 3, 4, 5 key points that live on the original graph of y equals cosine x. Okay, so it started at 0, 1 was the first key point, and then it goes to pi over 2, 0. All right, and then it goes to pi -1. Then it goes to 3 pi over 2, 0. All right, and then it ends at 2 pi and it's back up at 1 because now the outputs are going to start to repeat and the cycle starts all over again. So these are the 5 key points that live on the graph of y equals cosine x. All right, well, let's see what changes were made to the equation. There were not a lot of changes. This 6 on the outside is the only change, right? So you're doing 6 times the who? 6 times the y values, which would also then be 6 times the amplitude, but they didn't ask us about period and amplitude here, so we should be okay. So 6 times the y's. So that's what you need to do right now to all of these y values. So 0 stays the same. 1 times 6 is 6. That's a new point on the transformed graph. All right, pi over 2 stays the same. Take y, which is 0, times it by 6, it's still 0. All right, this point, pi stays the same because the x's weren't changed. Take -1, times it by 6, and you get -6. All right, take this point, 3 pi over 2 stays the same. Take 0, times it by 6, and you still have the point, the y-coordinate 0. All right, last point would be 2 pi, and then take 1, times it by 6, and that's your new point. So these are the new points that live on the new transformed graph. And then after this, the next 2 pi units, the same outputs start to come back out. All right, so let's go back to our graph. So we're still having a period of 2 pi, and when I divide that by 4, I'm still counting by an interval of pi over 2. So you can label your x-axis by pi's over 2 because the period and the subintervals did not change. So this would be 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2, and then your 8th pi over 2 is actually 4 pi. And you can go backwards too. This is -1 pi over 2, -2 pi's over 2 is -pi, -3 pi over 2, and then -4 pi over 2 is -2 pi. So you have all of your increments, all of your x values ready to go. All right, so if we graph our points now, we're going to get 0, 6. So 0, 6 now. Oh, am I on the graph? No. 0, 6 is up here. Then you graph pi over 2, 0. All right, then you graph pi negative 6. Then you graph 3 pi over 2, 0. Yep. And then you graph 2 pi 6. So again, the period is still 2 pi because we didn't change the x's, but now your graph looks like this on one cycle. It goes from 6 to negative 6, okay? And then again, the next ones are going to repeat again. So see how 1 is back to coming out? Well, then that means 0 would come out next. And then negative 1 would come out next because the outputs repeat. Then we'd be back to 0. And then we'd be back up at 1. So again, another 2 pi units and the same cosine curve is formed. Okay, and you could even go backwards. So if you're back up here at 1, then 0 is going to come out. Okay, and then negative 1 is going to come out. Or I shouldn't say negative 1, negative 6 I should be saying, sorry. And then you're going to go 0 is going to come back to going out. And then you're going to be back up here at 6. And then again, from 0 to negative 2 pi, another cosine curve has been formed. Okay, so now you can use this graph to answer any of these questions. Now I'm going to use the graph and I'm going to show you algebraically how you can answer each one of these questions, all right? But if you look, there's a pattern. If you start here, right, 6 came out. Then 0 came out. Then negative 6 came out. Then 0 came out. Then 6 came back out. And now 0 comes back out. And then negative 6 comes back out. And then 0 comes out. And then 6 comes out. There's a pattern to your outputs. 6, 0, negative 6, 0. 6, 0, negative 6, 0, 6, and so on. So you can use that as you go. Same thing. 0 came out for this input, then negative 6, then 0, then 6, and so on. So you see all of these angles that make these certain outputs come out, okay? All right, so let's go to question A. What is the y-intercept of the graph of f? Well, guys, look at your graph, and clear as day, what is the y-intercept? It's this point right here at 0, 6. So the answer is 0, 6 is your y-intercept. Well, another way you could have done that, in part A, it asked you for the y-intercept. The function is f of x equals 6 cosine x. Guys, just like any other graph, how do you find the y-intercept? What does the x-coordinate have to be of a y-intercept? It's got to be 0. So you plug 0 in, and whatever number comes out is the y-intercept. So if you found f of 0, that would be 6 times the cosine of 0. Well, what is the cosine at 0 radians? Guys, think of your unit circle. At 0 radians, what was that x-coordinate? Because that's the cosine. It's 1. So the cosine of 0 is 1. So that's really 6 times 1, which is 6. So your y-intercept is definitely 6, just like the graph showed us. Okay? All right, perfect. So part A is done. All right, part B says, for what numbers x, so remember, x goes in as an angle, so for what angles, in between, x has to be a number in between negative pi and pi. So you're looking at this portion of your graph, from negative pi to pi, right here on this part of the curve, from negative pi to pi. For what x values is the graph of f increasing? Okay, well, let's look. This one we need to look at the graph for. All right, so if you look at your graph from negative pi to pi on this interval, where is the graph of f increasing? Now remember, you read a graph from left to right. So when you start at negative pi and you start to go this way, what is the y value doing? As x gets bigger, f is getting bigger. So this is an increasing part of the curve. So it increases from negative pi all the way to an x value of 0. So from negative pi to 0, this is an increasing function. Once you get to an x value of 0, though, what does the y value start doing? It starts to go down. So it's a decreasing function from an x value of 0 to pi. All right, but they asked where it's increasing. So it's increasing from negative pi to 0. So you can write this as an inequality from negative pi less than or equal to, remember, they let you include the endpoints on the increasing and decreasing parts of the interval. So negative pi x is less than or equal to 0. So on these x values, it's an increasing function. Or in interval notation, it would look like this, from negative pi to 0. It's an increasing function, okay? All right, look at part C. What is the maximum value of f? Well, just look at your graph, guys. What is the highest value this graph ever reaches? It's clearly what number? 6. The maximum value of f is when y equals 6. Okay? All right, I crossed this one out because I actually asked you the same question twice, so I'll just answer it in this one. Okay, it says for what numbers x, so for what x values, what inputs, in between negative 2 pi and 2 pi. So you're only allowed to look from negative 2 pi to 2 pi. So this part of your graph, right there, from there to there, you're looking at these x values. What x values make this equation true? Well, it says for what numbers x that are in between negative 2 pi and pi does f of x equal 6? So basically for what x values go into this function and make a 6 come out? Well, look, we've already labeled 6 came out at an x value of 0. 6 came out at an x value of 2 pi. 6 came out at an x value of 4 pi. But we're not allowed to include him because he's not in the interval we were given from negative 2 pi to 2 pi. If you go this way, 6 doesn't come out again until negative 2 pi. So you can just look at the graph to answer this question. The x values that make this function equal 6 is when x equals 0 made a 6 come out, when x equals 2 pi, right? And then I have to stop because I was only allowed to look at x values in between negative 2 pi and 2 pi. Now you got to go this way. So what x values make 6 come out? Well, 6 doesn't come out again until an x value of negative 2 pi. And this says that I can include negative 2 pi and 2 pi as answers. So the next x value that makes a 6 comes out is negative 2 pi. Now, there is an algebraic approach to this question too. So let me show you that. So part E, right? Part E says, for what x values in between negative 2 pi and pi does f of x equal 6? Well, you could solve this. Remember who f of x was. F of x was 6 cosine x. So when does 6 cosine x equal 6? So get cosine x by itself, divide by 6, and cosine x equals 1. So you're basically asking yourself the cosine of what angle would have been 1. Now you can just answer this based off of the unit circle. So if you look at your unit circle, right? Okay, you had 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The cosine of an angle, the ratio was represented by the x-coordinate. So the cosine of what angle would have had a ratio of 1 in between 0 and 2 pi and 0 and negative 2 pi. Well, guys, what angles have a cosine ratio of 1? Right here, this angle right here has a cosine ratio of 1 at 0 radians. All right, if I keep going, he doesn't have an x-coordinate of 1. He doesn't have an x-coordinate of 1. He doesn't have an x-coordinate of 1. This has an x-coordinate again now, and after one rotation, what angle am I at? I'm at 2 pi. All right, and then again, you could go this way. Well, at 0 radians, it has a ratio of 1. And then he doesn't have 1. He doesn't have a ratio of 1. This angle doesn't have a ratio of 1. This ratio has an angle of 1. And what angle are you at now that you've made one complete rotation around in the clockwise position? That's negative 2 pi. So you could solve it algebraically and then a little bit of using your unit circle knowledge, okay? All right, let's go back to the next part of that question. Then it says, well, where does f of x, again, in between negative 2 pi and 2 pi, where does f of x equal negative 6? So what angles make a ratio of negative 6 come out? Well, you could go right to your graph. What x values make negative 6 come out? Well, we said negative 6 comes out right here, right, negative 6, and that was at an angle of when x equaled pi. All right, and then negative 6 doesn't come out again until this x value of 3 pi, but he's not in our negative 2 pi to 2 pi interval, so I can't include him. So right now it looks like pi is our answer. And then if I go this way, negative 6 doesn't come out until right there, and it happens at an x value of negative pi radians. And then I can't go any farther because I'll get out of that negative 2 pi interval they asked me to stay within. So this one says, well, when x equals pi radians, a negative 6 will come out. And at negative pi radians, a negative 6 will come out. So those are the two angles that live in between negative 2 pi and 2 pi that make a ratio of negative 6 come out. The angle pi radians makes it happen, and the angle negative pi radians makes it happen. And again, you could do the exact same thing that I did before algebraically. You could set 6 cosine x equal to negative 6, divide by 6, and go around your unit circle and find out what angles had a ratio of that negative 1 that you would have gotten here, okay? All right, look at part F. For what numbers x? Now this one says we cannot include negative 2 pi as an answer, but I can include positive 2 pi. So it's in between negative 2 pi and 2 pi, but not including 2 pi. Does f of x equal negative 3? Okay, well guys, look at your graph. From negative 2 pi right here to 2 pi. We're looking on these two cosine curves. We're wanting to know what x values, what angles made a ratio of negative 3 come out. Well, do you guys agree that negative 3 is right here? So what angles made a y value of negative 3 come out? Can't you see that there are 1, 2, 3, 4 angles that live in between negative 2 pi and 2 pi that make a ratio of negative 3 come out? There's 1, 2, 3, 4 answers to this equation. Now, negative 3 is right here. So you might not know what x value, what angle went in to make negative 3 come out. So you might have to solve this one algebraically. So let's go to our piece of paper. Okay, so it wants to know in part F, what's going to make f of x equal negative 3. Okay, so remember, f of x was 6 times cosine x equals negative 3. Well, let's get cosine x by itself so you can think of this in terms of the actual real function. So divide by 6, divide by 6. So now you're saying cosine x equals negative 1/2. So you're trying to find all the angles in between negative 2 pi and positive 2 pi that made that ratio of negative 3 come out. So you're trying to find now, what it boils down to, is the cosine of what angles would have had a ratio of negative 1/2. That's a special ratio. So that's a 30, a 60, 145, or some multiple of it. So guys, let's do this. So do you remember, was it the cosine of a 30, a 60, or a 45 that had a ratio of 1/2? Do you remember which one had a ratio of 1/2? Well, guys, think about it. All right, here's your 30, 60, 90 right triangle. All right. Which one, was it a 30 or a 60 that had a cosine of 1/2? Well, guys, if you did the cosine of a 30, that would be a over h. That would be root 3 over 2. So it wasn't the cosine of a 30 that had a ratio of 1/2. It was the cosine of a 60. So 60, the adjacent over the hypotenuse, the cosine of a 60 would have been 1/2. So you are dealing with a 60-degree reference angle, which in radians would have been a pi over 3. So now you got to work the quadrants. What quadrant would this angle have landed in to have a ratio, a cosine ratio that was negative 1/2? Okay. Well, remember, according to All Students Take Calculus, every ratio or every trig function creates a positive ratio in 2 quadrants and a negative ratio in 2 quadrants. So if we're working with cosine, All Students Take Calculus. Cosine was positive in quadrant 1, and he was positive in quadrant 4, which means his ratio was negative in quadrant 2, and it was negative in quadrant 3. So that means the angles that make this equation true are angles that are in quadrant 2 and angles that are in quadrant 3. And because the ratio has to be 1/2, you know it has to have a reference of pi over 3 radians. So what angles in the world of pi's over 3 landed in quadrant 2 and quadrant 3 in between 0 and 2 pi and 0 and negative 2 pi? Well, think about it, right? You have some angle in quadrant 2 that had a reference of pi over 3, and you had some angle in quadrant 3 that had a reference of pi over 3. What angles were they? Well, guys, this is pi radians, right? So in the world of pi's over 3, how many pi's over 3 make pi? 3 pi's over 3, which would make this 2 pi over 3, and it would make this 4 pi over 3. So that means the angles that have a cosine ratio of negative 1/2 are 2 pi over 3 radians and 4 pi over 3 radians. So in between one complete rotation, 0 to 2 pi, the angles that make this true are 2 pi over 3 and 4 pi over 3. So x would equal 2 pi over 3, 4 pi over 3. Now remember, we were also allowed to include negative angles. So if you were going in the negative rotation from 0 to negative 2 pi, your angles would still have to land in quadrant 3 and quadrant 2 to have a cosine ratio that was negative 1/2. But now what are you working with? This is where negative pi would be, right? So this is actually negative 3 pi over 3, which would make him negative 2 pi over 3, and it would make this one negative 4 pi over 3. So now negative 2 pi over 3 is an answer, and negative 4 pi over 3 is your other answer. And those are the 4 angles that would make this equation true. Those are the 1, 2, 3, 4 angles that make negative 3 come out of this function. Okay, in between 2 pi and negative 2 pi. Those are the 4 angles that make it true. Okay, now you also could have looked on your unit circle, and you are looking for the cosine to be negative 1/2. So what angles have an x-coordinate of negative 1/2? This one does right here at 2 pi over 3 radians. This one has an x-coordinate of negative 1/2 at 4 pi over 3 radians. So those are the same answers that we got. Obviously, this gets you it a lot quicker. I want you to see the algebra, though, in it. So it would have been 2 pi over 3 and 4 pi over 3. And then if you go in the negative direction, this again would have been your negative 2 pi over 3, and this would have been your negative 4 pi over 3 that make that equation true. Okay? All right, perfect. All right, then it says in part G. In part G, what are the x-intercepts of f? Well, guys, you can go right to your graph. At what x values does this graph cross the x-axis? It crosses at 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. It crosses at negative 1 pi over 2, negative 3 pi over 2. Obviously, it has infinitely many x-intercepts. So the x-intercepts are odd integer multiples of pi over 2. Odd integer multiples of pi over 2. Okay, and then the way we write that out in the fancy notation that we use is you would say when x equals, oops, sorry, I'm losing my paper over there. When x equals pi over 2 was the first one, and then plus or minus how many radians away from him is the next x-intercept? Well, pi over 2, if you think of it, is 90, and then 3 pi over 2 is 390 degrees, that's 270. That's 180 degrees. That's pi radians in between them. So then every pi radians after him times k rotations or revolutions is the next x-intercept, and that's just the fancy way you write it. Okay? All right, perfect. So again, I think these questions are a lot easier to answer if you just whip up the graph, and then you don't have to do all that algebra that's involved. You can just literally take your answers right off the graph. Okay? All right, I'm going to finish the last 2 parts in a separate video. I'll be right back.